Let's get started. For purposes of this demo, we are going to get you started by using the training CMM that is shipped and installed with QCCALC. The training CMM is a fake data generator that will allow you to become familiar with many of the features of QCCALC before you run it with actual inspection data. First, let's start QCCALC Real-Time. It can be found under Start, Programs, Prolink, QCCALC Real-Time. The first time you run QCCALC Real-Time, you will be asked to choose an inspection machine from a list of supported machines. Please select your machine type and click Finish. To help you set up your CMM to export inspection results, we will automatically show you machine-specific help. For now, we'll close this help screen since we are going to use the training CMM. To return to this help screen later, simply go to Help, Machine Specific. QCCALC has been designed to allow you to send data from your actual inspection machine and the training CMM tool simultaneously, so there is no need to tell real-time to look for data from the training CMM tool. The first time it is run, QCCALC will default to viewing sample data. Now let's start the training CMM. It is found under Start, Programs, Prolink, Training CMM. The only two fields necessary to run the training CMM are the part name and number of features fields. The four fields at the top of the training CMM tool are related to sending non-measurement trace fields to QCCALC and will not be discussed in this demo. For part name, type something that will not interfere with any production part names. For now, use myTest1. For number of features, type the number of features you would like to inspect. For simplicity, let's start with 16. Now click Inspect and watch what happens. The training CMM will act like a real CMM and create a file that is imported and displayed in QCCALC Real-Time. Click Inspect another 4 times so the plots show a total of 5 inspected parts on the screen. The numbers that appear are random, so they will hopefully be a little wilder than your actual measurements. However, it gives you a basis to start evaluating many of the robust features Real-Time offers. Depending on the numbers that are generated, you may see that some of the plots turn gray or red. As long as the actual values are within control limits, the plots will stay green. If the actual falls outside the control limits, the plot will turn gray, warning you that you are getting close to making a bad part. If the actual falls outside tolerance, the plot will turn red, indicating you have made a bad part and that your process needs to be fixed before continuing. These are all configurable, but will not be discussed in this demo. You may need to click Inspect a couple of times to see a bad part. Once you see a bad part, double-click on the plot to zoom in and take a closer look. When finished, double-click again to zoom back out. Now let's change the name of the part program to myTest6 and set the number of features to 6. We'll click Inspect a couple of times to get some points. You'll notice that QCCALC automatically finds the new part name and begins collecting and plotting the new data. Now we'll change the part name back to myTest1, set the number of features back to 16, and inspect new parts. Again, you'll notice that QCCALC automatically finds the new part name and picks up right where it left off with the original part.